Space is vast, an almost incomprehensible expanse that stretches beyond our wildest imaginations. It's teeming with objects of all shapes and sizes, from tiny specks of dust to massive celestial bodies. Some of these objects are harmless, drifting through the cosmos for eons without ever coming close to Earth. Others, however, warrant our attention due to their size, speed, or trajectory. One such object is Asteroid 2024 YR4, a newly discovered celestial body that has captured the interest of astronomers. Discovered in December 2024, this asteroid quickly garnered the interest of scientists around the world. Its discovery was a significant event in the field of astronomy. Why? Because its trajectory suggested a potential close encounter with Earth, raising both excitement and concern within the scientific community. While countless asteroids zip past our planet without incident, 2024 YR4 stands out due to its size and projected path. Its proximity to Earth makes it a subject of intense study. Estimated to be between 40 and 90 meters wide, it's comparable to a football field, making it one of the larger near-Earth objects. That's big enough to cause significant damage were it to collide with Earth, potentially leading to devastating consequences. The discovery of 2024 YR4 serves as a stark reminder of the cosmic hazards that share our solar system. It underscores the importance of continued vigilance and research in tracking these celestial neighbors. The possibility of an asteroid impact is a topic that often stirs anxiety, and rightly so. The consequences can be catastrophic, as history has shown us. But how worried should we be about 2024 YR4? Scientists use sophisticated models to assess the risk posed by such celestial objects. These models factor in the asteroid's size, speed, trajectory, and the gravitational pull of planets. In the case of 2024 YR4, initial calculations suggested a small but not insignificant chance of impact with Earth in April 2032. While this sparked concern, it's important to remember that these are early estimates. Further observations and refined calculations are needed to determine the actual level of risk. Understanding the potential impact of 2024 YR4 requires looking back at past events. One such event, etched in history, is the Tunguska event of 1908. Over Siberia, a massive explosion ripped through the atmosphere, flattening millions of trees across 800 square miles. The culprit, most likely a small asteroid or comet fragment, estimated to have been just a fraction of the size of 2024 YR4. The Tunguska event serves as a stark illustration of the destructive power of even relatively small celestial objects. While a direct impact from 2024 YR4 is unlikely, even an airburst and explosion in the atmosphere could release tremendous energy, potentially causing widespread damage and disruption. Luckily, we are not blind to the cosmic ballet happening around us. Scientists worldwide are constantly scanning the skies, searching for and tracking potentially hazardous asteroids like 2024 YR4. These cosmic detectives use a combination of cutting-edge technology and international collaboration to keep us informed. The hunt for potentially dangerous asteroids is a global endeavor. Astronomers, engineers, and computer scientists pool their expertise and resources. They share data, compare observations, and refine their models. This global network of cosmic guardians works tirelessly to ensure we have as much warning as possible should a threat emerge. Section 5. Eyes on the Skies. In this chapter, we delve into the fascinating world of astronomical observation and the technology that makes it possible. To spot these celestial wanderers, scientists employ some of the most advanced technology ever created. From ground-based observatories to space telescopes, the quest to understand our universe is relentless. Telescopes, both on Earth and in space, act as our eyes on the cosmos. They capture light from distant stars, galaxies, and other celestial objects, allowing us to peer into the depths of space and time. One such space-based observatory is NEOWISE, the Near-Earth Object Wide-Field Infrared Survey Explorer. Launched in 2009, NEOWISE has been instrumental in discovering and tracking near-Earth objects. NEOWISE specializes in detecting infrared light heat signatures invisible to the naked eye. This capability allows it to see objects that are otherwise hidden in the darkness of space. This allows it to spot even dark asteroids that reflect little sunlight, making it an invaluable tool in our planetary defense system. By identifying these potentially hazardous objects, we can better prepare for any threats they may pose. In addition to telescopes, radar systems play a crucial role in tracking and characterizing asteroids. These systems provide a different kind of data, complementing the information gathered by optical telescopes. By bouncing radio waves off these objects and analyzing the echoes, scientists can determine their precise distance, speed, shape, and even rotation. This multifaceted approach ensures a comprehensive understanding of the objects that share our solar system. Section 6. Charting the cosmic course. Once an asteroid is detected, the real work begins, charting its trajectory and assessing the risk it poses. This involves complex calculations that take into account a multitude of factors: the gravitational pull of planets, the radiation pressure from the Sun, and even the subtle Yarkovsky effect, a force caused by the uneven heating and cooling of an asteroid, all play a role in shaping its path. To make sense of this celestial dance, scientists use sophisticated computer simulations. These simulations combine observational data with physical laws to predict the asteroid's future path with remarkable accuracy. The more observations we gather, the more refined our predictions become. Section 7. Averting Armageddon. The discovery of potentially hazardous asteroids begs the question, what can we do to protect ourselves? These celestial bodies, often traveling at incredible speeds, pose a significant threat to our planet. If one were to collide with Earth, the consequences could be catastrophic, potentially leading to mass extinctions and widespread devastation. Thankfully, scientists and engineers are hard at work developing planetary defense strategies. These dedicated teams are exploring various methods to detect, track, and ultimately deflect these space rocks. Their efforts are crucial in ensuring the safety of our planet and its inhabitants. One such strategy is the kinetic impactor, a technique dramatically demonstrated by NASA's DART mission in 2022. The Double Asteroid Redirection Test, or DART, aimed to test whether a spacecraft could successfully change the trajectory of an asteroid through direct collision. The DART mission successfully altered the trajectory of a small asteroid by crashing a spacecraft into it. This mission was a monumental step forward in our ability to protect Earth from potential asteroid impacts. This groundbreaking experiment proved that we can, in principle, deflect an asteroid on a collision course with Earth. By carefully planning and executing such missions, we can potentially prevent a disaster of epic proportions. Another promising approach is laser ablation. This innovative technique involves using high-powered lasers to gradually change the course of an asteroid. This involves using high-powered lasers to vaporize material from the surface of an asteroid, creating a jet plume that acts like a thruster, slowly nudging it off course. By continuously applying this method, we can steer potentially dangerous asteroids away from Earth, ensuring our planet's safety for future generations. Section 8. Lessons from near misses. While the prospect of an asteroid impact is a sobering thought, it's important to remember that near misses are far more common than actual collisions. These close encounters, while potentially unnerving, offer invaluable opportunities to study asteroids up close and refine our planetary defense strategies. One such near miss involved the asteroid Apophis. Initially thought to pose a significant threat to Earth, further observations and refined calculations showed that Apophis posed no immediate danger. However, its close approach in 2029 will provide a unique opportunity to study its composition and test our deflection technologies. Section 9. Guardians of our planet. The ongoing saga of Asteroid 2024 YR4, like those of countless other celestial objects, underscores the importance of continued vigilance and investment in planetary defense. As we peer deeper into the cosmos and our understanding of the universe grows, so too must our commitment to protecting our pale blue dot. The work of scientists, engineers and policymakers is crucial in this endeavor. By supporting space exploration, funding scientific research and fostering international collaboration, we can ensure that humanity is prepared for whatever the cosmos may throw our way. After all, we are not just inhabitants of Earth, we are its guardians. Let us act accordingly.